Hey everybody, it's Mr. Carr again. Today we're going to be finishing up Unit 6 with our 6.3. It says day 2, but really it's just a combine of multiple days here, but it's not too bad. The last thing we want to do with our triangles is talking about congruent triangles. I know it's been a while, but we talked a little bit about congruent figures in the past, saying like this triangle is congruent to this triangle. Being congruent means that the two things are exact copies of each other. What we've done in the past was that we were looking at everything had to match up. All the sides and all the angles have to match up for two figures to be congruent. Well, with triangles, we actually have shortcuts. So this is a matter of determining whether or not the entire triangles are copies of each other just based on some minimum information. And so that's what we're going to look at here. The first one is called side-side-side congruence. If three, and we're going to shortcut that as SSS. If three sides of one triangle are congruent to three sides of a second triangle, then the two sides. What? No. Then the two triangles are congruent. Okay. So how that looks like here is that we have that matches up to that, there to there, and there to there. So three pairs of sides are congruent. I can now make the statement that triangle ABC is congruent to triangle RST. And I picked the order of those letters on purpose because when I look at ABC, okay, let's highlight that, like orange, okay, A to B to C. You look at the order I went in. I went at, A is at in between sides 1 and 3 there, and then I went up to B and C. So I kind of traveled this path of the 1 tick mark, then 2 tick marks. Okay, RST does the same thing: 1 tick mark, 2 tick marks, and then that 3 tick marks there. Okay, so when I make my congruency statements, it needs to be in that exact order, or it needs to be in an exact order like that. I could switch this around and say triangle BCA is congruent to triangle STR. Okay, as long as it matches up. And again, another kind of a flashback to when we did this before, you can identify certain things like angle B and angle S are congruent to each other. Angle C and angle T are congruent to each other. Angle A and angle R congruent to each other. So, does SSS exist here? Well, in the case number 1, I think the A and B were supposed to be spread out a little bit differently. So in this first case, yes. Okay, so yes, I do have side, side, side. The reason why is because here's one pair of sides. Here's another pair of sides. Here's the third pair of sides right there. This side is called reflexive. Okay, and that reflexive is whenever I take the two triangles, smash them together, and they share a side. So these two triangles are enough. Now, it doesn't say the directions. I can now make the statement that triangle, let's go with JLK, is congruent to triangle MLK. And again, I made that the right order of I started here, J and M were in the corresponding positions. Then I went up to the 9 and down here to K. Same M up to the 9, down to the K, like that. In the second one, I have two pairs of sides. I have those 3 tick marks and 2 tick marks. But what about the last ones? Don't know. Not enough information. So there's no, I'm going to say no in this case. All right. Nothing else to do there. I just identify it's not there. So this is our first shortcut, side, side, side. The next one is called hypotenuse leg. So hypotenuse leg is if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of a second, I should say second right triangle, then the two triangles are congruent. Okay, and this is labeled as hypotenuse leg HL. So the key part about this one is it has to be two right triangles, and it has to be a leg right here. Here's one. Here's my legs in the scenario. So here's my two legs, and then here's the hypotenuses. Now there is a way to do it with right triangles of the two legs, and like the two pairs of legs, but that's going to get to something similar to what we do later. Okay, and again, needs to be right triangles. So when I look at these three scenarios, A, B, and C, the first thing I want to check is, are they right triangles? Yes, they are. Now I'm going to look for, can I show a hypotenuse and leg that match up? So in example A, I can. Here's my pair of hypotenuse or hypotenuses. Here's my reflexive one. Okay, since I have that BC is reflexive, it is a part of both triangles. So yes, I have HL here. And again, I'll take it one step further. I'm going to say that triangle ABC is congruent. Let's see here. So triangle A, or A is down here. That should match up to D. And then B and C are going to match up from where they're at. So I'm going to say that triangle ABC is congruent to triangle DCB. All right, number 2. Okay, we have right triangle. We have hypotenuses that match up, but I don't have any legs that match up. Okay, so that's the one thing that's getting me here. I don't have any proof that any legs match up. Okay, so there's nothing else I can do with that one. Here for part C, this one's a little bit more, but I actually can show this. Okay, the reason why I can show this is if I look at a right triangle, let's remember a Pythagorean theorem. Here's a leg, and a hypotenuse. I can take 3 squared plus 4 squared equal to h squared there. So that's 9 plus 16 equals h squared. Oh, I forgot to write no here. 25 is equal to h squared, and then I'll square root that, so that 5 is equal to h. So that means that's 5 there. And look what I have. Got 2 hypotenuses and 2 legs. Okay, so what I showed is these two are congruent and these two are congruent. So yes, I do have hypotenuse leg here. And then I'm going to go ahead and go one step further and say that triangle, let's go ARM is congruent to triangle. So I went A to R to M like that. So I went 3, then 4. So I'm going to go triangle JRK. Okay, there it is. There's hypotenuse leg. Got 3 more of these examples. Next one is called side angle side. It's a little bit complicated, but let's make sure as long as we can pay close attention, we should be able to get this. So side angle side is when if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. So when I say included, I am referring to these angles right here. Included is in between the 2 congruent sides. Okay, so we have here these match up, and then these match up, and my angles here are in between and congruent to each other. This is how I know I have side angle side. So do I have enough in these 2 scenarios? Let's take a look. I have my angles here match up. My sides here match up, and here match up. And are the angles included? Yes. So therefore, yes, I do have side angle side here. And I would say that triangle DKA is congruent to triangle, I'm not a huge fan of that one, but DKA should be SKT. Okay, part B. Now I have a right triangle. I have 2 right triangles here. Not a huge, okay. I want to tie this back into our side angle side because this is actually a really good diagram. Like when I look back earlier, where'd it go? Yeah, this is exact same diagram as example 2A here. But I'm going to modify this a little bit because I want to demonstrate something with our right triangles. So instead of having congruent sides here, get rid of those. Instead, I'm going to do this. I'm going to make these 2 congruent to each other. Okay. The reason I did that is I have right triangles. The first thing I always say is when you see 2 right triangles, check hypotenuse leg. The way I have it drawn now, I don't have hypotenuse leg because I'm pretending that I don't know that the hypotenuses are congruent to each other. Okay, so instead, I'm going to take it a little bit further. Can I show side angle side here? The answer is yes. Side angle side I can get because I have side, and the included angle. So even though they're both 90, I could consider them to be congruent. So I'm going to say yes for side angle side in my new scenario here. So I'm going to say yes, side angle, side. And now I can make the statement that triangle ABC is congruent to triangle DCB. The last two, we kind of put them together because they're very similar to each other. Angle side angle and angle angle side. They're almost interchangeable because here's the thing that I know. It's got its own formal theorem, but if I look at this scenario that I got two angles on the included side of one triangle are congruent to two angles on the included side of a second triangle, then the two triangles are congruent. So that's what I have here. Included are these two sides. That's what I'm referring to. Again, included, in between. Compare that to angle angle side, which is if two angles on the non-included side of one triangle. I don't know what's with this type of 1 and 1. Okay, are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So again, so angle side angle, we got like angle side angle, angle side angle. Okay, sides are included here. Angle angle side, angle angle side, angle angle side. It's not included. But here's why they're kind of interchangeable. If I have two triangles and I know that this angle matches up to that angle and that angle matches up to that angle, what do I know about the third angles there? They got to match up. There's no way if I have two angles that match up to, if I have two angles of one triangle match up to two angles of another triangle, they have to match up for those third angles. So in all honesty, angle side and angle side angle are almost interchangeable. Kind of just depends on what I give you. Like, so for example, these right here, is there enough information to prove that the triangle is congruent? So example 4a is very good because it helps us with a key piece of information. I don't have any side length information here. Nothing here is congruent on the sides here or the sides here. I cannot prove congruency. I cannot show that two triangles are congruent unless I have at least one pair of sides. Like, let me highlight these real quick. We have side, 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 hypotenuse leg, side angle side, angle side angle, and angle angle side. The one thing that's common in all five of these examples is that there's at least one side, one pair of sides that need to be congruent. Okay, so when I look at A, that's going to be no right off the bat because there's no congruent sides there. So I don't have to even worry about it. Part B, I do have a pair of congruent sides because it's reflexive. Is that reflexive side in between the two angles? No. So instead I have yes, it's angle, angle, side. Okay, I've got angle, angle, side, angle, angle, side. Last one here, I have a pair of sides, so we got a good start. Have a pair of angles, don't seem to have a second pair of angles, except I do, because I do have vertical angles. So some of those angle properties are coming back still. They're not going away because we get to use vertical angles here. So now what I have is angle, side, angle, angle, whoops, angle, side, angle. So I got a yes again for angle, side, angle. So how these work, they work towards what's called proofs. Okay, I'm going to show you proofs. I'm probably not going to emphasize this as much in class, but bottom line is proofs are used to show that something is true or false. Okay, I've kind of informally done a bunch of proofs, and actually you have too when you describe your work and explain your reasoning for certain things. So what I'm going to do here real quick is I'm just going to kind of show how a proof works in this case and example 6 here. But it's more important from this lesson that you recognize what, does it have angle, side, angle? Does it have side, side, side? All right, complete this proof. We're given this information. Proofs are always going to start with givens. So this statement here is written here, and then this one is written here. And my reason there is going to be given. Every statement needs to be backed up by a reason. So I'm actually giving you this one. I gave you the angle ABE, which is right here, is congruent to DBC. So what reason is that? I said it earlier. Vertical angles. Okay, and that's all I need is that quick little description there. Well, now that I have that part, if you look at the scenario, I have this angle and this angle matches up to that one, and these two angles match up there. the sides also match up. So if two angles and a side that match up, side is not in between the two angles. So I can say that the two triangles are congruent. The reason, angle, angle, side. That's where we can kind of use these 5 reasons. We can use them in these proofs. But again, I'm not going to really emphasize this in class or in our assessments at all. The last thing is something that's called CPCTC. Corresponding parts of congruent triangles are congruent. So what that means is if two triangles are congruent, then all their corresponding parts are congruent. And so what that kind of means, let me just show this as a brief example here. Let's say I have triangle ABC and triangle CD, not C, DEF. Okay, and let's say I can say that these are congruent and these are congruent and these are congruent. So based on this information, I know that the two triangles are congruent because of side, side, side. Okay. In addition to that, since I know that the two triangles are congruent, I also know that angle A and angle D have to match up. These are the corresponding parts that are congruent because the two triangles are congruent. So that's what we're demonstrating with this. This is the shortcut, CPCTC. Okay, so I can show that any pair of corresponding parts are congruent once I've shown two triangles are congruent. So in this little brief example here, if I show that in this scenario, I look at, let's see here, why are the two triangles congruent? ADK is congruent to TSK. So ADK is congruent to TSK because of side, angle, side. Sides, angle, sides. Now that I've shown the two triangles are congruent, I can now show any of their pieces are congruent. So AD right here and TS, those are congruent because of CPCTC. Angle ADK, which is this angle here, well, I look for the corresponding angle for that is going to be this one. So that's going to match up to angle TSK. Okay, so that's it for proving congruent triangles. So that's it, and that's it for our triangles for this unit. So we are going to wrap up unit 6 now. We are, again, focusing on how do we find that two triangles are congruent. There are 5 reasons right there. There's my shorthand of the lesson. These are the 5 things that are bare minimum of showing two triangles are congruent to each other. Okay. We can also use those as part of a proof, as kind of an explanation. Why, like if I need to explain it step by step how I know that two triangles are congruent, I can show it in this like proof style here. And then the last thing is, once I show that two triangles are congruent, I can show any of their corresponding parts are congruent. All right, so that's it for 6.3 here. Have a nice day. We'll talk more about Unit 6 later, and take care.